Welcome to ECO2Fuel Perspectives, the podcast that brings you insightful conversations at the forefront of sustainable energy and the fight against climate change. Brought to you by the ECO2Fuel project, an innovative initiative under Horizon 2020's Green Deal program aimed at revolutionizing the production of economic and sustainable liquid e-fuels and chemicals. We will guide you through this intriguing world of sustainable energy. We'll delve into pioneering research and inventive solutions that are reshaping our future. Join us as we engage with top-tier experts and stakeholders to dissect and unveil the latest breakthroughs in carbon capture and utilization. We'll navigate the complex interplay of science, technology, and policy, explore challenges, celebrate triumphs, and shed light on the potential of carbon capture and utilization technologies for our environment, economies, and society at large. Whether you're a passionate advocate, a dedicated researcher, an influential policymaker, or just curious about the future of energy, you're in the right place. Prepare to broaden your horizons, rethink established paradigms, and gain a refreshing perspective on the journey towards a sustainable, flourishing world. Don't forget to subscribe to our podcast for the latest episodes and join us on our social media platforms for engaging conversations. Together, we can help sculpt a cleaner, greener future. I'm delighted to have you along for this journey. Welcome to ECO2Fuel Perspectives.
Welcome in our ECO2Fuel podcast. My name is Clémence Contant. I'm the communications manager of Meta Group. We advise and lead exploitation and dissemination activities for EU-funded research projects in many sectors such as renewable energy. And in that case, we are leading the dissemination and exploitation for the ECO2Fuel EU-funded project that is the producer of this podcast. In today's episode, we are diving into two specific renewable energy technologies. These should contribute to reduce our carbon emissions and to find alternatives to fossil fuel. The world is facing a climate crisis due mainly to the burning of coal, oil, and natural gas that release massive amounts of carbon dioxide in the atmosphere, contributing to global warming and its devastating consequences that we know. This is why the European Union's Green Deal set ambitious targets to achieve a carbon-neutral continent by 2030, aiming to reduce of 55 greenhouse gas emissions compared to the 1990 level. This urgent situation demands a quick transition to cleaner renewable energy sources. The recent energy crisis has highlighted the importance of diversifying our energy resources in order to reduce our dependence on fossil fuels. So, the most famous renewable energies, such as solar and wind energy, have seen significant advancements in recent years, improving their cost and efficiency. The same is happening for the geothermal and hydropower resources. So for our audience, the geothermal is using the Earth's internal heat, and the hydropower taps into the energy of flowing water. So as we know, there are also other alternatives, such as bioenergy, biomass, and e-fuels, for example, that are less known, but they are still under development. So this is the topic of our episode today. And we will explore the latest development of these technologies through two specific projects, BioFlexGen and ECO2Fuel. These two projects are funded under Horizon 2020 program of the European Commission. And we will discuss about the challenges and the opportunities for biomass with BioFlexGen and the CO2 conversion with ECO2Fuel. So welcome to Michael Bartlett and Deepak Pant. Michael, you are CTO, Chief Technology Officer, and co-founder at Phoenix Biopower. You are one of the partners of the BioFlexGen project. Thank you for joining us.
Thank you for having me. Thank you.
And Deepak Pant, you are the Senior Scientist in the Sustainable Chemistry Department at VITO, and you are one of the pioneers of the ECO2Fuel project, the CO2 conversion related one. So welcome, Deepak.
Thank you very much. Happy to be here.
Thank you, Deepak. So we're going to start with our guest, Michael, our guest project. Could you please introduce us a bit what biomass is, what are a bit the challenges, and what are you trying to achieve with the BioFlexGen technology?
Thank you, Clemens. BioFlexGen is a project that is developing new technology to address the challenges of the future energy system. Bioenergy has, of course, been around for a long time as a part of humans' energy use. We are focusing particularly on residues of biomass. That is what is left over after other main processes have utilized, for example, forestry or farm products. So an example would be that after you make planks of wood, you of course have lots of sawdust left over, you have bark left over, you have little branches which you can't make planks out of left over. So all those things are the types of residues that we try to utilize in our process. The advantage of this, of course, is that it's a complement to the variability that you get from the new types of renewable energy from solar and wind. As we all know, the sun doesn't always shine and the wind doesn't always blow. And so you have gaps in the electricity production, which is where biomass can play a role. It is already used today in a lot of countries, for example, in the Baltics and the Nordics, to produce heat and power for cities. So you heat your houses with district heating, and you use the electricity, of course, in your appliances and your homes. What we try to do is to get even more electricity out of the biomass than today's technology. So we foresee up to twice as much electricity from the same amount of biomass to the cities. Now, this means that you can increase quite radically the amount of local production of electricity for a house or for a city. And this leads to a lot of good effects for the energy system. The technology that we're using is a unique combination of gasification and gas turbine technology. Now, this is different from today's technology, which is more that you have a boiler where you burn the biomass, you produce steam, and the steam turns a steam turbine generating electricity, and then you condense the steam producing the heat. We instead gasify the biomass into a high quality fuel. We use that fuel in the gas turbine, and in the gas turbine, we can produce a lot more electricity than with the steam turbine. So that is the main innovation of the technology, is to be able to switch from today's steam turbine technology to the future's gas turbine technology.
And Michael, how do you make flexible your technology for future systems?
Good question. The basic plant is the gasification plant and a gas turbine plant. Now, of course, we have the flexibility of renewable energy day and night, and also across seasons. So we introduce one type of flexibility across the seasons, is that when heat is not needed, so in the summer, we can actually switch from production of electricity to the production of hydrogen. So that is one seasonal flexibility which we do via the gasification system. The other type of flexibility you want to have is that when there's no sun or wind, you want to be able to run the gas turbine quickly. And that's where we utilize hydrogen as a fuel. So we actually have multiple, let's say, abilities in the plant, from producing heat and power to producing hydrogen to, in the last place, actually consuming hydrogen when we need electricity. All these things we are actually demonstrating in a small pilot plant here in Stockholm, where we have an atmospheric gasifier connected to the gas turbine combustor, and we utilize gasified biomass sometimes, we use hydrogen sometimes, and we've proven this flexibility between those fuels is feasible.
Thank you, Michael, very clear. And I was wondering also if you have some demonstration sites where you are testing this technology.
Yeah, so in addition to the pilot plant we have in Stockholm, where we test the gasifier and the gas turbine combustor and switching between hydrogen fuels and biomass fuels, we also have sites in northern Sweden testing the gasifier itself at larger scale. And we have a site with our partners in Berlin, where we're testing the combustor at high pressures. So all these elements together bring us to what is called a technical readiness level of 4, which means that they're ready to go to industrial conditions.
I will pass it to you, Deepak, with the CO2 conversion technology. Could you give us an overview, a simple overview on what are the challenges, but mostly what is the advantage of convert CO2, and which sector also maybe can really benefit on this, and also what are we doing really with ECO2Fuel project for the for the e-fuel production?
Thank you. So there are several aspects that you touched upon here. I will start with the first one. Why CO2? So because as you know, our world is in a big transition right now, and the emphasis is really on moving away from fossil fuels, but also become energy independent. And especially Europe, in the current geopolitical scenario, would like to have energy self-sufficiency and reliance. And for that, we need to have resources. Of course, when you think of resources, the first one that comes to mind is biomass, as Michael explained previously, which is a resource rich source, not only in Europe, but for the rest of the world. It can be imported and then can be converted through projects like BioFlexGen. But then that the amount of biomass on land is rather limited, and to go and it cannot sustain all the energy needs that humanity requires. So that's why, in search of alternative feedstocks, CO2 was considered already some decades ago as an alternative. But in the last 10 years or so, it has increased tremendously to consider CO2 not as a gas which only pollutes the atmosphere and cause the global warming, but also as a resource which can be captured not only from atmosphere but also from industrial point sources like cement industry or steel industry, and then converted into fuel. Now, how does ECO2Fuel come into picture? This is a very ambitious project funded under the Green Deal initiative of the European Commission, and it's building a one of its kind first electrolyzer in the world, which has and when completed, the ambition is to reach 1 megawatt. And with an intermediate, currently we are at 50 kilowatt scale. The pilot has been designed, built, and already the factory acceptance test has been done. When the project is finished, we will reach a technology readiness level, as is common in European parlance is called. We will reach a TRL of 7. So that's the basic idea, to produce liquid fuels that can replace or add to the fossil fuel feedstock, starting with CO2 as a resource and only using renewable electricity or renewable energy as the power to drive this process.
Thank you, Deepak. And I believe also for ECO2Fuel, we are testing on some demonstration sites, right, to make sure that we achieve this TRL 7, as you mentioned before.
Correct. Currently, the project is 2.5 years down the line since it started, and we are at an intermediate stage. And very important milestone has been achieved last month, where this 50 kilowatt electrolyzer is built, and the project partners, including the coordinators DLR, visited us, and the project officer also came to VITO in Belgium. And now we are doing the testing at our location, but eventually it will move. The pilot it's a kind of a containerized system with all the safety precautions and everything included in it, and it will move to our partner site RWE, which is the coal energy production site in Nederhausen in Germany, where it will be tested with the CO2 captured from the flue gas of their power plant and tested on site. So that's where we are right now. So indeed, it's a demonstration site where the system will be tested under real conditions.
Having heard the two stories, Deepak, Michael, what will be the common challenges you see in those two technologies?
So continuing on the CO2 electroconversion side, there are several challenges. Some of you already mentioned, but if I have to rank them, I will say the stability of the process is one of the biggest challenges. A lot of these systems, and ours is not the only project working on this technology. There are several projects, not only in Europe, but across the world in the past that have been completed, but most of them have remained at lab scale. And at lab scale, the tests are carried out only for a matter of hours or a few days, which is not enough to demonstrate to the industry that your process is stable and can run over several thousand of hours. And that's one of the most important challenges that we are trying to address in ECO2Fuel. Then comes the target of productivity. So you want to have as high productivity as possible, and that's another thing. And the third thing, challenge is about the selectivity of the process. So when you are using electricity to convert CO2 into a product, you want that almost all the electrons or the power that you are providing goes into making that product, and you want to avoid side reactions or byproducts, which you anyway have to then separate and which increase the total cost of your process. So the selectivity is also quite important. And of course, the final challenge is to reduce the cost. So I always say this, technologically, a lot of things are possible, but are they also economically feasible? So to bring the technology to scale is one thing, but to do so at being cost effective is quite another. And that's another important aspect we try to address in ECO2Fuel by doing a very extensive techno-economic analysis.
Very good points. And I would say, as we are both developing quite complex process technologies, there's a lot of commonality there. Of course, we need to also prove functionality, and then over time reliability and availability. These things are perhaps a little less critical because we're earlier in the development process, but certainly proving functionality and optimizing yields or efficiencies are core, and you must have techno-economical assessments in order to guide your decisions on designs and scaling up. So those are certainly central. And I'd say, on a broader perspective, of course, we're both addressing the need for transitioning away from fossil energy sources into renewable sources, and perhaps different sides of the coin. When we're looking more at the electricity side, producing and making sure we have a stable grid with local production, decentralized production, whereas you're looking more on the consumption of electricity with stable local production of fuel instead, and the fuel is utilized, of course, in the system. So I think there's a lot of interesting things to talk shop about in terms of technology, but one thing which I think is curious is that, as I mentioned, we have a feature where we're going from electricity production during the winters to hydrogen production during the summers, and that could also just be a standalone plant always producing hydrogen. Now there you need to separate the CO2, and that's biogenic CO2, which is, of course, probably a potential feedstock for you guys. So those aspects also kind of in a way interlock. So I'd be curious if you guys can actually take CO2 directly from any sort of gaseous form, or you have an intermediate separation step, which you then get a pure CO2 from.
You touched upon a very, very interesting point here by bringing in the biogenic CO2, because there has been a lot of emphasis from the European Commission side. A lot of calls are specifically focusing on biogenic CO2 per se, because the ratio of biogenic CO2 compared to other industrial sources has been increasing. And another advantage of biogenic CO2 is the concentration of CO2 in such streams is relatively higher. So then for the next conversion step, it becomes relatively simpler with less purification steps involved to convert a biogenic flue gas rather than, I would say, commercial industrial flue gas. So that's a very good point that you made. The link, the biogenic CO2 can be very nicely fed into the electrolyzer, such as being developed within the ECO2Fuel project. But yes, and if the stream, flue gas stream in general is very complex, yes, a pre-purification step is indeed needed.
Interesting. And are you targeting smaller scale applications, such as, let's say, I mean, you're attaching it to a very large coal plant. Is that the envisioned scale, or you're thinking more about decentralized applications?
So the technology itself can be decentralized, should be decentralized eventually, because we are working across the TRL value chain. So we are working also on the very fundamental Pathfinder kind of projects, for instance, where the technology is developed. But the vision is ultimately to have decentralized, or as they call it, prosumer. So your production and consumption at the same site with minimum amount of storage and transportation involved. That's one vision that Europe is looking for, and we are working towards it. But of course, the large industrial setups, like mentioned, 1 megawatt, it will be more or less a stable production chain. And then we will have, of course, the downstream of the alcohols, because in our case, it's the alcohol is the fuel that can be either used for blending. For instance, gasoline, you always need this ethanol for blending with it. This E95 type of fuel that you get at the filling station, but of course also as a source for chemicals that can be used in the feedstock for the industry that are currently using it, either importing it from outside Europe or making it through fossil routes. So both possibilities are there indeed.
Mm-hmm.
Thank you, Deepak. Thank you, Michael. I can see some synergies could be possible between these two systems. How do you see that in the end user sector? So I can hear that CO2 conversion would be more for maybe transportation, Deepak. Maybe if you could go deeper with that. But for biomass, Michael, you're more working on the electricity grid and heating resources. So how does this go? How does this work?
If I could jump in there, I think with the technology we're developing, we have, as I mentioned, we have the gasification system, which is converting the biomass into a gas called a synthesis gas, and you can use that in different applications. And if you're very rigid in your cleanup and purification steps, you can utilize the syngas from biomass directly in, for example, process industries to produce different types of chemicals, different types of plastics, different types of materials. So we choose in a first step to utilize it in a gas turbine because the purification requirements are less and we can get a lot more, let's say, utilization from the biomass. So we're focusing on the electricity, but we do see in a second step, and that's why we're looking at this pathway with hydrogen, that you can utilize the chemical content of the biomass, the gasified biomass, in different applications. For example, hydrogen production, alcohol production, etc. And those in themselves can be utilized in the process industry, just like Deepak was saying about the alcohols that he produces. So there are different ways of bringing in molecules into the different processes that you see in our society. And I think these are two different ways, one in gasification and one is the electrochemical way. Yeah.
And in our case, the end users can be considered as two sides. So one is the industries which are producers of the CO2, so CO2 emitters, so to speak, and it could be combustion power plants, not only fossil based but also bio based, just like Michael mentioned. But also steel and cement industry are actively looking for such solutions. Chemical industry in general is an end user, and of course transportation sector, as you mentioned, Clemens, is indeed the one of the intended recipients of the project at the end.
Thank you, Deepak. Thank you, Michael. This is indeed very interesting, and that can touch very different sectors. And I was also wondering what would be a concrete impact to communicate today for the citizens, for the large audience that is listening to us. What do you foresee for the society?
Well, BioFlexGen is targeting, of course, local production of electricity from biomass in combination with heat production. And what that means actually for a European citizen is that you get reliable supply of electricity and heat produced locally. It decongests the grid, which means we can produce more renewable of a variable type, and allows industry in the end to be established in these areas. So it's employment. Its cost is in terms of bringing down the cost of electricity. It's security of supply, as in being self-sufficient, and it of course brings up job opportunities within, of course, the industries that can establish because we have low prices and stable production, and the jobs directly formed within, for example, the bioenergy sector, where you have the collection and utilization of the biomass residues.
So indeed, so citizen, the end user of any technology development is the common citizen. If it does not reach, there is the less point of developing the technology. One of the challenges of such technologies is also the public acceptance, because when you come up with a new technology and you try something which is not their usual way of seeing things, consuming things, then there is a little bit of a fear among the end user or the consumer. So to address the public perception of the products, but also the technology that you bring to the society is very important. And ECO2Fuel has I think a dedicated work package addressing this public perception. And what we are trying to do there is to educate or impart this information to bring to the general public that how the fuels that will be produced eventually by adopting this technology will be non-fossil based. They will be completely or most of the time produced by using renewable electricity. The share of renewable electricity is going up with each passing year in Europe. And at times there is certain overproduction. So that overproduction of electricity can be directly used to produce fuels from CO2 as a feedstock. It can also be seen as a local and decentralized production, which eventually will lead to creation of a new type of sustainable industrial chemical sector, providing jobs to the citizens and the youth who are entering this sector right now. So that's the role of the citizen or the how we address the citizen point.
Thank you, Deepak. Thank you, Michael. Indeed, thank you very much for this discussion. We could hear all the main challenges. So from what we understand today is that biomass or CO2 conversions have some common challenges such as the stability or the scaling up, as you said, which is also linked to the public acceptance, but in the end also to the in between the industry acceptance to bet basically to go further with other alternatives, which is still a long road for this kind of technologies. But thanks to this kind of projects such as ECO2Fuel, BioFlexGen, we have big hopes to go further with this acceptance. This is very important, as we know, for sustainable resources in the future. And the impact also economically, as you said, in the energy sector, so for citizens. So this is why I would invite also our audience to carry on listening the other podcasts of ECO2Fuel. This is the topics we're trying to cover. So the next podcast will be more about the EU policy for the CO2 conversion. The next guest will be a CO2 Value Europe Association that will present a bit the overview of the European policy regarding the CCU technologies, so the technologies dedicated to the CO2 conversion. For more information about CO2 conversion, you can also listen to the first episode of ECO2Fuel, which is more on the technology. This one, be ready, is a bit more technical. If you want to meet in person and know more about more technical results about the BioFlexGen project, you are invited to their final event because, Michael, this is the end of this funding project, but this is not the end of the technology development, of course. So you're invited in November the 20th and the 21st in Brussels. The event will take place at the European Bioenergy Futures event, and we are waiting for you at the Blue Point venue. You can find all the information about the event and the technology on their website, bioflexgen.eu. And we hope this discussion inspired you to get more and more input about this alternative. And I thank you very much, Michael. Thank you, Deepak. And I hope to have more renewable energy adventures with you maybe in the future for other projects.
Thank you.
Thank you
for having me.
Yes, thank you for having us. Yeah.
We'll be back soon with more thought-provoking discussions and groundbreaking discoveries. Until then, remember that every small step towards sustainability counts. Let's continue to explore, innovate, and transform our world for generations to come. ECO2Fuel Perspectives is a production of the ECO2Fuel project under Horizon 2020's Green Deal program. To learn more about the project and access additional resources, visit our website at www.eco2fuelproject.eu.